8.3, the graphs of sinusoidal functions. So today what we're going to do is we're going to explore the graphs of y equals sine x and y equals cos x. So let's start by graphing y equals sine graphs. And I'm hoping what you're going to get out of this is showing you the relationship between, using the shape of the graph, showing the relationship between degrees and radians. So I'm going to bring up, oh, look from yesterday, how beautiful is that? So first things first, I'm going to get us into degrees, okay? So I'm going to make degrees flashing, I'm going to hit enter, and what I'm going to do is I'm going to make sure that my y min is at negative 360 and my y max is at positive 360 because it goes through, the trigonometric ratios go through their full cycle from 0 to 360. So if I were to go into my equation editor here, and I'm just going to say clear, clear, and just have room for that sine x. I'm going to graph it. We're noticing that between negative 360 and 0, we have one full period. Now what we mean by that is one full shape of that sine graph before it repeats again. So what I'm going to do is I'm going to find out what these zeros are and I'm going to plot them. So I'm going to go second trace and I'm going to say zeros, enter. And I'm pretty sure that this is going to be at 0, 0, do, 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 do. Look at that. So we have a point on the graph, y equals sine x at 0, 0. Let's go back. What about the other zeros? Oh, sorry, second trace, and I want to find 0. So I'm going to go to the left bound. I'm going to just invest in this time here. Left bound, right bound, enter, and we are at negative 180. So what I'm going to put in, and this right here is going to be our left most bound, which is going to be negative 360. So if on my graph here I put negative 360 degrees, so that just means instead of rotating, so when we say positive 360, that means we're going in this direction. When we say negative 360 is when this is 0, 90, 180, and then all the way to 360. But the way that we would do it is negative 90, negative 180, to negative 360. So it's the same line. But I'm just showing you where that is placed in standard position. So I'm going to say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So actually, I'm going to change this a little bit. I'm going to say that actually this right here is my negative 360 degrees. So I go 1, 2, 3, 4, 5, 6, 7. So we know that there's a 0 happening there. And 1, 2, 3, 4, 5, 6, 7. Perfect. And we know that 1, 2, 3, 4, 5, 6, 7, there's going to be another 0. And we're going to go in there and see what that should be. 1, 3, 4, 5, 6, 7. And the last 0 happens at positive 360. Now if your gut tells you that this is going to be, since this is negative 180, this is going to be negative 180, I think you're on to something. But let's just double check. So I'm going to go second trace. I'm going to figure out what my 0 is. Come on, buddy. There we go. So this is where my left bound is. This is where my right bound is. Enter. Ah, yes. This is going to be at positive 180. This right here, negative 1.5. 1.75 e to the negative 13. That's just essentially a computer rounding error. Don't worry about it. This says that it's negative 1.75 times 10 to the negative 13. So let's just let's take a moment, okay, off to the side. That literally means that it's 1.75 times, negative 1.75 times 10 to the power of negative 13. Okay, that means we're moving 13 decimal places to the right. So if I'm going 175, so that's literally going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whew! So this, this is literally how small it is. Can we just say that it is actually 0? Because it is so close to 0. It just is based on the calculator's way of rounding. And it wants to be as precise as possible, but like for me, 0 is good enough. Okay, so we're just going to go back here. And we're going to say this is going to be positive 180, not 120, silly. Positive 1, I write a 2 again. Positive 180 degrees. So let's just go back here. All right. What is this value here? So what I want to do is I want to go second trace, and I want to hit the maximum. Actually, do you know what? I'm closer here, so I'm going to go to the second trace. Oh, sorry, second trace. I'm going to hit the minimum. So the left bound of that minimum is here, because it's to the left of that little bump. Enter, enter. So the minimum happens at 270 and y equals -1. So if I say that, I'm just going to use my scale here. I'm going to say this is -1 and 1, 2, 3, 4, 5, 2, 3, 4, 5. I'm just making it so that equal distance. So 1 literally is 1. So in between these two, I go down to 1. The minimum happens at 170. So if I can go here, this is going to be 270, not 170, 270 degrees. And I bet another minimum, or sorry, I bet the maximum happens halfway between 180 and 0. Let's just double check. Second trace, maximum. So I'm going to go back. Oh, come on, buddy. There we go. Left bound. Going over. Right bound, enter. Well, look at that. The maximum occurs at 90 in the x and 1 in the y. So here's a maximum right here. This happens at 90 degrees. And if I were to connect my dots, really for a sinusoidal, I need to have 5 different dots. 1, 2, 3, 4, 5. Once I have those 5 dots, I can just connect them in a smooth way. Now what we're going to do is we're going to continue this pattern. So when we get to -90 degrees, what do we hit? We hit a minimum. So that's going to be at -1. When we hit -270 degrees, we're going to hit a maximum. So that's going to be at +1. There we go. So there is our graph of y equals sine x. Beautiful. Now, I'm going to go a little bit faster with the cosine x, but I just really want to hit home that 360 is 2 pi, 180 is pi, and so on. Okay, so let's just go back here, and I'm going to change. Okay, I want us to go into the mode. So I'm going to go mode, and I'm going to hit radians, and I'm going to graph it. Now you're going to notice, ah! What happened? Now we're noticing that it's kind of going between 1 and -1. But let's change our window. So remember, if we're saying 2 pi, that's going to be 2 times 3.15. Okay, so that is just under 7. So I'm going to say from -7 to... Actually, do you know what? I'm going to go from -2 times pi. I've changed my mind. To +2 times pi. You're going to see the exact same function as we saw here. Let's graph it. Look at that. So, what we get here is going to be pi. So my gut is telling me that this intersection here, this 0, is going to happen at at exactly 3.14. So let's figure it out. 0. Let's find that 0. So I'm going to just scroll on over. Enter. Enter. Look at that. This intersection happens exactly at, well, we went through my spiel before, 0 in the y and 3.14. So this right here, if we were to put it in a value here, we would say 180 is the same thing as pi. Double 180, you get 360. Double pi, you get 2 pi. Woohoo! That's yummy. So same thing, negative 360 would be negative 2 pi, and 180 would be negative pi. Halfway between 0 and pi, you guessed it, would be pi divided by 2. And then this is 1.5 pi, so we're going to say 3 pi over 2. This one is the same here. We're going to say that this is negative pi over 2, and this is going to be negative 3 pi over 2. So let's do the same thing in our cosine x. But I'm going to use the same values here, but you'll see how they're different. So I'm going to say here we're going to go 1, 2, 3, 4, 5 for a positive one, 1, 2, 3, 4, 5 for a negative one, and I'm going to go here to positive 360 degrees. Halfway through is going to be 180 degrees. This guy right here is going to be 270 degrees. This guy right here is going to be 90 degrees. 902. Same thing is going to happen here. Okay, so we have negative 360, negative 180, negative 90, don't forget your degrees, and negative 270. So I'm going to switch back to degrees here. So I'm going to go mode, degree, and we're going to go into our graph, and instead of sine x, I'm going to say cosine x. And I'm going to graph it. Oh, hold on, maybe that didn't take. Let me just double check here. Ah, I know exactly what happened. Let's go into our window settings. We need to change it. When we get into degrees, we should go from negative 360 to positive 360. I'm going to graph that. There we go. That's the shape we like. So you'll notice that in the cosine graph, the maximum happens at 0 and at 360. So I'm just going to put those in, maximum and maximum. And we can just read off the graph. The value of this is just 1, because we have from positive 2 to negative 2. So it's just going to be 1. Our zeros happen at 90 and 270 instead, and our minimum happens at 180. Okay, so this right here would be half. So I'm just gonna, like, this is not hocus pocus or anything like that. I'm gonna figure out where that minimum is, and I bet it's going to be at 180. So I'll just check it out. Enter. 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 And look at that. 179.999999999 forever. So essentially, this is kind of the same thing as, 10 to the negative 13. Essentially, it is going to be at 180. And we notice that it's actually symmetrical. It's perfectly symmetrical. So I can just graph. Okay, there's going to be a 0 at 90, a negative 1 at 180, a 0 at negative 270, and right back up to 360. Right back up to 1 at 360. So when I connect the dots, again, 1, 2, 3, 4, 5 dots for a full period. Woo. Just like that. And if I wanted to be really specific, I could say that this is pi, this is the same thing as 2 pi, this is negative pi, and this is negative 2 pi.